All right, well, this is lesson 1.3. This is titled Piecewise Functions. And the biggest thing that we're going to be looking at is, depending on what our value of x is we are changing what equation we're going to use. And that'll kind of make sense a little bit more here as we do a couple of these. So let's get started. So it says, suppose the function f is defined for all real numbers as follows. So what this is saying is this part right here, let me get a different color, okay, is if x is not equal to -1, so if we have any value whatsoever of x and it doesn't equal -1, then we're going to use this top function. Okay, we're going to use this top equation. Okay, if x is equal to -1, so this bottom one, then we use that one. Okay, so what we're looking at here is this first one is f of -3. Well, is -3, like if I plug it in right here, does that not equal -1? Well, yeah, that's a true statement. So what I'm going to do is I'm going to take this right here and I'm going to plug in the -3 wherever I see the x. So I've got 1/3, and make sure you are using parentheses here. It will change your answer. Okay, anytime you do substitution, you need to use your parentheses. Okay, so we're going to do our exponents first. So we've got 1/3 times by -3 squared is 9. Then we're going to minus 5. And as we multiply 1/3 times 9, that's going to give me 3 minus 5. So f of -3 is equal to -2. Okay, that's the first one. Okay, so now we're going to look at this second one right here, and it says f of -1. So my x value is -1. Well, that satisfies this criteria right here. So as we look at that, x is equal to -1. So that's a true statement. So f of -1, and it just gives me a -2. Well, that's my answer. Done. Okay, now let's look at this last one, f of 4, and that is going to make this one right here a true statement. So once again, we're going to plug it into our equation. So I've got f of 4 is equal to 1/3 4 squared. So instead of x squared, and then minus 5. It's going to be 1/3 times by 16 minus 5. It's going to be 16/3 minus 5. And let's see. I'm going to change this to 16/3. If I times this by 3/3, it'll give me 15/3, which will give me 1/3. So that is your f of 4. Okay, so once again, we're just looking at what input value we have and where can I put that to make a true statement out of these multiple functions. Okay, so here we have another one. Okay, once again, it's -1. It's not always going to be the case, but here we have -4. So -4 satisfies this requirement. So this is going to be the equation we use. So -1/4 times by 4 plus 1. Well, -1/4 times 4 is going to be -1. So add 1. Remember, this is our f of -4. Oh, it's negative, which changes that, because negative times a negative is a positive. Add that together, gives me a 2. So f of 4, -4, equals 2. Okay, so, or I guess it's h, sorry. Okay, so here I've got h of -1, and here, this makes a true statement here, -1 is equal to -1. And if that's the case, I'm going to use that line right here, which just means that this is -3. Okay. This last one is 3, so that's going to be right here because 3 does not equal -1. So that means I'm going to be using this function here. So h, let's see, h of 3 is equal to 1/4 times 3 plus 1. And that's going to give me 3/4 plus 1. So 3/4 plus 4/4 is equal to 7/4. So h of 3. Okay, there we go. That's how we do that one. Okay, let's look at this next one. Okay, this one has 3, and we're going to be satisfying some different requirements. So if my number is less than -2, so like infinity all the way to -2, right? This one's -2 to 2, and this one is 2 to infinity and beyond. Okay. So I've got, my first one is 1. Let me get a different color here. So 1. If I plug this in here, well, is 1 less than -2? No. So it's not the first one. Okay. If I plug in a 1 right here, does that make that a true statement? Is -2 less than 1, which is less than 2? Yeah, that is a true statement. So I'm going to be using this right here for h of 1. So h of 1, that just means y, right? It's a function, equals, and then I got 1 plus 1 squared minus 1. Okay, 1 plus 1 is 2 squared minus 1 is 4 minus 1, which is 3. So h of 3 equals 3. Okay, so now I'm working with a 2. Now this is where this one's a little bit tricky because I do have a 2 right here. But is -2 less than 2, which is less than 2? No, that is not a true statement. It is a true statement down here because it is the greater than or equal to sign. So this part right here is important. Okay, so this makes this a true statement. So I'm going to use this one, which is going to be -1/4. So this is our h of 2. Then I plug in my 2 plus 2. So I got -2/4 plus 2, which is -1/2 plus 2. I can rearrange this as 2 minus 1/2, which is going to give me that 3/2 or 1/2. So h of 2 is equal here. Okay, the last one, h of 4. Where's that going to make that a true statement? And that's actually in the same one because 4 is greater than or equal to, well, greater than or equal to 2. So that's what I'm going to use as well. So I got h of 4 is equal to -1/4 times by 4 plus 2. That's going to be -1 plus 2. And so that's going to be 1. So h of 4 is equal to 1. Okay, let me do one more of these and we'll kind of move on to a different one. Okay, this follows similar criteria. We just need to figure out where this -4 or whatever number we're working with makes a true statement. So if I plug it in here, -4 is less than or equal to -2. Well, that's true. So h of -4, and then my equation is just, well, it's just -1. So I'm done. Check. All right. So now let's go green. I got 0. Let's plug in a 0. Is 0 less than or equal to -2? No, that's not right. What about this one? -2 is less than 0, which is less than 1. Yep, that's the one that we're going to be using here. So I got negative, then I got 0. And I always like to put what I'm substituting in its own parenthesis. Square that, plus 1. And this is our h of 0. Okay, that's just our function. So we got negative, and then 0 minus 1 is -1, squared plus 1. And then we're going to square this, so that negative is still there. -1 squared is 1. And then -1 plus 1 is 0. So h of 0 is 0. And then let's get a different color. I'm going to plug in a 1. So let's plug it in right here. If I plug in a 1, well, -2 is less than 1, which is less than 1. The first part's true, but the second part is not, because 1 is not less than 1. 1 is equal to 1. And that's why this one works right here, is 1 is greater than or equal to 1. So if I go h of 1 equals 1/4, and then 1 plus 1, well, that's going to give me 1/4 plus 1. So that's 1/4 plus 4/4. It's 5/4. So we have 3 separate answers for that one, and most of them that we've done so far. Okay, this one gives us 4 different criteria that we need to look at. And all we need to do on this one, there's actually not a whole lot of math or solving that we need to do. We just need to make sure that we put the number in the right spot. So I'm just going to go one by one. Okay, if I did this as a -1, well, is -2 less than -1? Yes. Is -1 less than or equal to -1? Yes. So h of -1, right, this checks out, is equal to -1, because that's what I have on my left-hand side. Okay, what about 1.5? Okay, let's put it in. 1.5. Well, -2 is less than 1.5, yes, but is 1.5 less than -1? No. So that doesn't work. Okay, -1 is less than 1.5, yes, but is that less than or equal to 0? No, so that doesn't work. 1.5, 0 is less than 1.5, which is less than or equal to 1. No, that's not true. And then 1 is less than 1.5, which is less than or equal to 2. Yeah, that one's true. So h of 1.5 is equal to 2. And lastly, I think we can just kind of start down here at the bottom, because that's, okay, 1 is less than 2, which is less than or equal to 2. Yeah, so h of -2 is also 2. Okay. Piecewise functions look at parts of your graph at a specific time, each part of as a restricted domain. A domain is our x values, right? So domain is our left to right values. You can only draw the graph within the domain. And remember, if we have a greater than or less than, these are open circles. So let me kind of get that. Open circles. And then here, whoops, because it's greater than or equal to, these are closed circles. Okay, and that just has to do with when we're graphing, like so. Okay, suppose the function is undefined. Okay, if x is equal to 0, so left to right, if x is equal to 0, or if x is not equal to 0, I'm going to kind of get a little bit thicker of a marker, see this a little better. And if it's not equal to -0, so let's just plug in a couple points. Let's just plug in, like, I don't know, -2, -1, 0, 1, 2. Okay. Well, here I can't have it be 0 because it says x is not equal to 0. So what I'll do is I'll go to 2 and I'll go down to 1. Well, I got a dot there, I got a dot there. And if I go to 1, it's still on -1, and it goes on forever. So it's actually making a line all the way up to and including. But when x is 0, and this marker is a little thicker than I want. When x is 0, so right here on the y-axis, right, this is where x equals 0. It's going to jump all the way up to 5. 1, 2, 3, 4, 5. And I'm going to put an open circle. Here, let me get a bigger open circle. So, actually, that's a closed circle because it's equal to. And we have an open circle right here. There we go. That works better. So there's this gap. There's this hole in this continuous line. All right, this is going to bug me now. And it just jumps up just when x is equal to 0, and then it goes back down to the negative 1. Okay? So if x is less than 0, it's going to be 2. So all the way on this left-hand side, all the way up to here, then we have this open circle. And I need to get a thinner marker. Okay? If x is equal to 0, it goes to negative 2, which is right there, and that's where it's equal, so we do have a closed-in circle. And then if x is greater than 0, so on the right-hand side of that axis, we're going to go to negative 1. There you go. So we've just got this jump, right? If it's on the left-hand side of 0, if it's less than 0, the graph is at 2. Once it hits 0, it goes down to negative 2, which is our closed circle right there, right? And then when x is to the right of 0 or greater than 0, it's at negative 1. So that's why I have a closed circle, because it doesn't include that spot. Okay, let's do another one. This time it's not 0, it's 1. So if x is less than 1, okay, our value is going to be 2, just like it was. But it's going to cross 0, and then we're going to have an open circle right there at 1, because it doesn't include 1 there. Okay, if x is equal to 1, we're going to have a closed circle right there on 0. That's our y value. And then if x is greater than 1, so we're going to do an open circle, and then we'll continue that way. All right, this is the last one. You'll probably see one or two of these on Alex. We just need to put some lines and make sure our circles are right or close. So you notice right here, this is an open circle. I'm going to just kind of put these. This one's a closed one, so it does change a little bit. That one's open, 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 and then this one's closed. This one's closed. Okay, so if x is negative 2.5, and I'm going to count these, so like this is 1 or negative 1. This is negative 2, negative 3, negative 4, and so forth. So I'm going to do where each one is a half. So we got 1, 2, 3, 4, and that's as far as we need to go. So from negative 2.5, I'm going to go negative 2.5, and I'm going to have an open circle, and it's going to be a negative 3. So 1. So let's give me an open circle on that side. Then we go over to negative 1.5, which I didn't start in the right spot. There we go. Okay, it's open on the left, closed on the right. This is the one we're looking at right here. Okay, I'm going to choose a different color. Oh, shoot. Whoops. Okay, get a different color here. All right, so now we're looking at this one, and that's from negative 1.5, and that's going to be open to negative 0.5, which is closed. Okay, so now we're here, so we're negative 0.5. Oh, that needs to be up one. Sorry, I forgot I did my just my differences here. Okay, so now let's go green. So we've got an open circle, and it also ends with an open circle because they're both less than characters, not the greater than or equal to. Okay, and then what color am I going to use? I'm going to use blue. So left to right, if it's equal to 0.5, so that would be here. Then we do have an open circle on the left this time. There, and then last, let me grab purple. Then we got 1.5, and we got closed circle. This is our purple. Our value is 1, so that looks good. And there we go. So that's what those ones are going to look at. On these ones, you guys, on Alex, they're always going to go up 1 over 1, up 1 over 1 every single time. But I didn't tell you that. Okay. Well, have a good one. I'll see you next time.